Welcome back to the next session on SSAS 2014. So in last session we discussed about data source view and let's discuss about dimensions and cubes and measure groups in this session. So before starting with the dimensions, so how to create dimension and what is dimension and all, let's see a couple of options like we have a build, rebuild and deploy and also process options which are very important to understand before starting the, about dimensions and cube development. So first let's see what is build. Build, normally it will check for the syntax errors. If there is any syntax error, then it will check and it will throw the syntax error. And let's see an example. Don't concentrate much. I'm gonna create a dimension pretty quickly, which we will be discussing about it very soon. But let me create one dimension to demonstrate what is build, what is deploy, and what is process. So let me select dim date, click on next. Let me select all the attributes, click on next and finish. So I've created a dimension and I use the table dim date to create the dimension. And here, if I go to the dim date, I'm converting it into a name query and I'm taking out one column. Let's say, for example, I'm going to take out calendar quarter. Okay. Now, if I go to dim date dimension, you can see the calendar quarter, it is showing as red underline. It's underlined in red color, saying that the data source view does not have this particular column, but you're using this as attribute. So in other words, the dimension or the dimension object or the cube object, whatever you are going to create using the tables on the data source view, the structure should be in sync with the data source view. Now in the data source view, there is no column called the calendar quarter, but in your dimension, you used it. So what does it mean? It's a syntax error. So something is missing. So if I try to build this solution, if there is any such syntax errors which you have missed, then it will pop up an error message saying that there is an error that calendar quarter is missing in the data source view. So that is the main purpose of building the project. Now, when you see such kind of errors, what you need to do is you need to correct it before you proceed further with the deploy and process. So to correct it, you can do two things. If you don't want this attribute, let's say you don't have it in your data source at all, and if you don't want this, you just delete it. So now your dimension is not referring to any column from the data source view which is not available in the data source view table. Now if you build it or if you click on rebuild, it will check for the syntax errors, and on the bottom left you can see where my mouse is highlighting, you can see the rebuild all succeeded. So that means if there is any syntax errors, it will fail and it will give you a heads up saying that there is a problem and you have to fix the problem before proceeding further. So that is about the build and rebuild. It basically check for the syntax errors and it will throw error message if there is any syntax errors. The next one is deploy. So deploy is basically to deploy the skeleton or the structure to your analysis server. For example, I think I deployed it a couple of days back, some sample databases. Let me delete it. Okay, I've deleted it and I've deleted it. Now this is my analysis server. I just connected it using the option by selecting the analysis server and by providing the server name. Now let me display the object explorer and let me disconnect it and let me show you once again because I quickly did that. So if I click on connect, it will ask you to select the server type for connecting to the analysis services, and for seeing all the analysis services databases, you need to pick analysis services and provide the server name, and you are very well versed with what is server name. So click on connect, it will connect to the analysis services and it will show any databases if there are any on the analysis server. And now let me go and deploy it. So deploy, basically, if you remember, This is your underlying database or your data warehouse or OLTP or your relational database. And here this is your analysis service project. And here it is your analysis server where you'll be deploying the databases. So when what normally will analysis services will do, if you create an analysis services database, that means it deploys the structure here. That means it deploys the skeleton of the project. Skeleton in the sense, let's see what is the skeleton of the current project AdventureWorks GW. The skeleton is, it has one data source. The name of the data source is AdventureWorks, and it has one data source view. The name of that one is AdventureWorks GW 2014, and it has some XYZ number of tables, and the table structure is so and so many named queries, so many. So it basically deploys the XML whatever you have seen to the server. So the skeleton will be deployed to the analysis server. So let's see quickly by deploying the project. If I click on deploy option here, then all this XML part will be deployed to the analysis server. Let me show you that by right clicking and click on deploy, and it is deploying AdventureWorks to the local host. That means your local computer. That's the default one when you connect to the SQL Server data tools. If you want to deploy to the different server, you have to provide the server name. I'll show you once we discuss about the deployment. There are a lot of ways to deploy the project, and I'll be showing you a lot of examples on that. So now you can see that deployment completed successfully. Now if I go back to the analysis server and if I click on refresh, you can see the database structure has been deployed to the analysis server. So this is the skeleton of your database which you are created using the SQL Server data tools. Now the last and final one and the most important one, the deploy and the process. What process will do? The process will read, see, when you click on process, first it will make sure whether it has the structure or the database has any syntax errors or not. That means the output of the build, if there is any syntax errors, it throws error, right? So the same way it will check whether there is any syntax errors or not. If there is no syntax error, then it will check whether the structure is already deployed or the structure that is there in the database, analysis services database, is same as what we are trying to process or not. If it is same, it will go ahead. If there is any changes in the structure, then it will ask there is some change found in the database, analysis service project. Do you want to deploy those changes to the analysis service database or not? If you click on yes, it will deploy the changes, and then the third step is it will read the data from your relational database and it will write to the analysis server. So the process will do three steps. The first one is build and then the deploy, and the third and main one is the actual one of the process, meaning is like reading the data from your relational database and writing it to the analysis services. Now if I right click and click on process, you can see it is asking me, it's given the option like you are trying to process the AdventureWorks GW. It is the database and you're doing process full and parallel processing, and some properties are set which we'll be discussing in the processing options session. Now if I click on as run, it will read the data of each and every object and it will place in the, for example, in our case we have only one object created. The only one object which we created is dimension, that is dim date. So if you go here, you can see each and every attribute or each and every column data has been read and written into the analysis server. And remember, the queries of each and every attribute, you can get it when you expand the processing dimension attribute blah blah blah. If you expand this, you can see SQL query 1, and if you select this and click on view details, let me erase the drawings, you can see the query. So this is nothing but the SQL query that has been sent to your underlying database to pull the data for this particular attribute. In the same way, you'll find query for each and every attribute. So when you click on process, what it will do is it will go, it will send the queries to your relational database and it will read the data and it will write the data to your analysis server, and at the end it will create aggregations and indexes on top of the data that is written to your analysis server. So this is about build, deploy, and process. And remember, if you click on build, it will just check for syntax errors. That means it will do the job of build. And if you click on deploy, it will first check for syntax errors and it will deploy and then it will deploy the changes to your analysis server. That means it will do the job of build and deploy. And when you click on process, it will check for syntax errors and it will check for the structure in the analysis server. If there is any changes, it will try to deploy and then it will process. So it will do all the three steps, that is build, deploy, and process. If you click on process, now you got clear picture about what is build, deploy, and process. And now let's see what is a dimension. So in last session we discussed about how to identify a dimension table and when a table will be called as a dimension table. So it's basically most of the cases it's the master table in your SQL Server or the underlying relational database, and also it should have some textual information which is required for your analysis services, for your business analysis services. And also it should have primary key, basically because there should be at least one column which is unique. Now let's see. Um, let's try to create a dimension. So for creating the dimension, you need to right click on the dimensions folder here, and you have an options called new dimension and new link dimension. We will be discussing about the link dimension in the next session, which is not so important or which is not frequently used by the developers, but I'll show you what is the link dimension. And for now, let's click on new dimension, and the welcome wizard will give you a little description about the dimension and all. When you click on next, you have multiple options like creating a dimension using the existing table in the sense the tables that you can see in your data source view. So whatever tables that you have added to your data source view means this use an existing table. So you cannot use the table which is not added to your data source view and which is there in your underlying database unless you created a named query on top using that particular table. And the remaining options like creating a timetable in the data source, creating a timetable on the server, generate a non-timetable, and the non-timetable you have different templates. So it's basically for the second one, third one, and fourth one, it gives a template. And in those three, for the second and third one, it also gives you the data, which we will be discussing very shortly. So now let me go ahead with use an existing table. Click on next, and here you can select the data source view in which you have that dimension table which you will be using for creating this particular dimension. In our case, we have only one data source view, and I'm leaving it as is because that's selected by default. And what is the table on which you are planning to build the dimension? In this case, let me go ahead with dim customer. So I'm using customer table, and when I selected the customer table, the key column is selected as customer key, and the name column is selected as customer key. And let me click on next, and here you need to select the columns that are required for your analysis purpose. Let's say I don't want first name, last name, and middle name. I think I have full name. No, I have not added full name. So for now, let me take first name and last name and gender, and yeah, this should be more than enough for now. So let me click on next. So this is my dimension name. I can name it as customer for better look and feel and better naming convention, right? And these are my attributes, or in other words, the columns that I have added from this particular dimension table, which I think are which is part of the requirements or which are required to meet the requirements. So if I click on finish, it will create the dimension, and it will be split into three panes. The first one on the right is data source view. That means the table that you have used to create this particular dimension. So this is the table, and if you want to see the sample data, you can right click and see the sample data. Okay, so that is on the right hand side pane, and the mid pane you will find hierarchies. So if you create any hierarchies, you can that will be shown in the hierarchies pane. And the left side one is attributes. So the attributes in the sense is nothing but the column of the dimension table. Okay, so I've selected 4 attributes, and among those 4 I have one key attribute. So the key attribute is very important in dimension. So the key attribute plays the key role in the dimension, to be honest, and this key attribute should be always unique. If there is any duplicate data in the key attribute, then it will throw error message saying that there are duplicate records in your dimension table. Okay, now why this is important, let me quickly show you that why the key attribute is very important here. Let me show you that. So now let's say what is this customer products class. Okay, let me go ahead with customer. What is this customer? This is not the right one. Okay, let me close this. Oops. So let me take a new workbook, that is better. Welcome to Excel blank workbook. Yeah, this is perfect. So I selected blank workbook, and let's say I have a product type, or let's say I'll go with product name and color and cost and unit, something like this. And let's say product I have A, color is blank, cost is $10, and unit is 1. And I have a B, blue, and $15, or let's say $10, and unit is 1. And A, again the product, another product name is A. They can be the same product name. So the color is, but the color is different here. Let's say the color is blue, and same amount, let's say $10, and the unit is 1. And some cases, okay, some cases there'll be just a duplicate of product information or the data, so it remains the same. So in this case, if you ask me what are the black color products, I can give you this one and only one product, that is A. And if you see what is the blue color B product sales, so there is one product which is on the second row here, and the same combination is here in the second in the fourth row. And if anyone asks me A color product, so I can give you this information. But when it comes to the complete row uniqueness, if the dimension does not have the complete row uniqueness, then it will say it can't figure out the difference between this record and this record. That means if there is data for B color product, it does B product, then it will be confused what data it belongs, I mean for which row it belongs to, or for which master record it belongs to. So it's always advisable and it's always good practice to have the unique column for every dimension table. And the other one is like let's say the pretty common name is Shiva in India at least. So let's say there are 3 Shivas, okay, both from Tirupati, or all the 3 guys from Tirupati. And let's say everyone opens a savings account. Might be the last name is different for the, let's say Shiva D, Shiva B, Shiva C. Let's say the last name is different. Now here, if you ask for the information, let's say get me the savings details of the user Shiva, you can't get that information because there are 3 guys with the same name Shiva, right? And how can you identify it? You can identify it by using the last name here. Last name is the only difference in this particular case. Let's say our bad, there is one guy whose last name is also the same, like let's say Shiva Chirala, Shiva Chintalpuri, but the short name they used, and both both are showing as C. Now if you ask for give me Shiva C details, which one you're going to give, the third one or the fourth one? And when you deal with the money matters, then it's very risky if you don't have a unique column which uniquely identifies each and every row. So that is why everywhere it talks, I mean, people talk with IDs. Let's say there will be customer key or customer number, right? Or account number. So in this case, let's say the account number is the unique one. So this guy has 1, 2, 3, 4. If you ask me about the Shiva's details, give me Shiva's details, then I'll ask what is his customer number or customer account number. So there should be some unique way to refer each and every dimension member. So that is what we call as key column. Now, if I have the key column, then I can easily find out where the guy is, who is the guy that we're talking about. And this ID will be used everywhere. That is why few company badges, they print only employee ID, not even the name, just photo and employee ID. Because there should be some unique way to refer. If anyone call me like Rupesh or Shiva or Lagnajit in the company, there may be so many guys in the company with the same name. So it's very difficult to find out which Lagnajit you are talking about. So the uniqueness will be provided by the key column or the unique column, the distinct value column, I mean the unique column of the table. So in the same way, every attribute or every dimension member should be uniquely identified, and for that purpose we need to have one unique column which we will be calling as primary key column in our case, because we use master tables in most of the cases. If you have to use transaction table rather than master table as your dimension, then you have to make sure that there is a unique column in the particular table, or else you cannot use it as the master table or dimension table. So let me show you an example. Before going to that, let me quickly process this and show you whether it will be successful or not. It should be successful because the dimension table, this particular table is unique. I mean, this particular table has unique column, that is key column, sorry, customer key, which we are using as key column while creating the dimension. Now this process successfully, and the data is read, and if I see these four, there will be SQL queries sent, and it read the data and everything is fine. Now analysis services has data about the customer dimension. Now let me go to the table. Let me connect to the SQL server from where I'm pulling the records for customer table. Let me connect to this. I think this is the database, AdventureWorks TW 2014. Let me go to new query. Select star from team customer. So this is the table. Let me see how many columns are there. There are a lot of columns. I have to provide value for all these columns now. Okay, let me see what are the non-empty columns or not null columns. Let me go to team customer. A lot of columns are there. So if you see here, the customer key is defined as primary key. So there is no way that you can insert duplicate value into this column. So that is why master key can be, there should be a master table can be used as your dimension in analysis services. Let's say you are not using a master table where the primary key is not set, then the chances of inserting a customer key, a duplicate value, is very much high. So in that case, if you process your analysis server, then it will fail. If you process this particular dimension, then it will fail because there are some duplicate key column values. Now we have created one dimension using one key column, and keep in mind, if you have a duplicate data in this particular key column, then it's going to fail. The dimension will not be succeeded if you process. Now let me try to create another dimension. I hope you remember you remember, like I said many times, design your data source view properly. If you don't design it properly, then you have to do a lot of manual work. If you design it properly, it will reduce your work. Let's see an example for that. So now I'm trying to create a dimension. Click on next and use an existing table. Fine, click on next, and the table that I'm going to use here is dim product. And when I select dim customer, I can see the key column got selected and the name column got selected, but here nothing was selected. What was the reason? What is the reason here? The reason is pretty simple. I didn't design the data source view properly for dim product table. Let me click on dim product so that it will be highlighted, and if you see, the key is not defined here, the logical key, because this is a name query. I removed the key column. So what I'm doing here is I'm setting the logical primary key, and I'm going back to create the dimension and click on next, and if I click on dim product, now you can see the key column and the name column is selected. So this is the advantage of designing it. This is one of the advantages of designing a proper data source view. And if you want to use composite key, sometimes, right, it's not always one column, primary key column. There'll be sometimes composite, like two columns used as a primary key. So how you can achieve the same in analysis services? See, this is the key column window, right? This is the key column section where you'll be selecting the key column. And here I can select another column too. If I want to select 3 columns, I can select. But how many key columns you select, that doesn't matter. That will be those. Let's say I selected 3 columns here. These 3 columns will be used to uniquely identify each and every row of the dimension table. Now, when you select like this, you need to select at least one or any column for the matter of the fact, any column as the name column. So we'll be discussing about the key column and the name column differences, which is very important to understand in the dimension concepts. So this is how you can select multiple columns as your key column. For now, let me take out this because I don't want this. Because my product key is primary and it does not have any duplicates. Let me click on next, and let me name it as product and click on finish. Okay, now my product table, dim product table is used to create the product dimension. And what are these? These are nothing but the dimension columns, product dimension table columns, what we call in analysis services. The master table is called as dimension table. The transaction table or the metric table is called as fact table. What is this column called as? What are the columns of the dimension table called as? The columns of the dimension table are called as attributes. So attribute is nothing but one column of a dimension table, and the column of the metric of the transaction table, which will be used as a fact table, is called as measures. So if I draw this is your database. It will have two types of tables, master and transaction, right? And the factless fact table, which is not of high priority, but we'll be discussing about it. So let's say if the master table meet all the requirements to become a dimension table, we call it as dimension. In analysis services, we'll create a dimension using it. And we create measure group or fact table using the transaction table if it meet the requirements, like having the metric information and having foreign key relationship with the dimension tables, and also foreign key relationship, and if it is a transaction table. Now every column of it is called as attributes. So this is one attribute, one column of it. This is attribute, this is attribute. So every column of it is called as measure. Okay, so we will use two or more attributes to create a hierarchy. We'll use one or two or three or even zero measures to create a calculated measure. So on top database, we'll have two types of, like, mainly we'll be creating either dimension or measure group, and each column of the dimension is called as attribute, and each column of the measure group is called as measure. And we will use 2 or more attributes to create a hierarchy, and 3 or more, 0 to n number of measures to create a calculated measure. 0 means you can hard code some values, like you can provide some 1, 2, 3. You can provide some hard coded values or some constant values, in which case you don't need measure groups. So we will be discussing about this a lot when we talk about the cube designing. Now, what we have created, we created a dimension called product and attributes called Arabic description, Chinese description, class, color, days to manufacture, and all. So once you add it, once you create a dimension using the dimension table, alias master table, alias primary key table, alias um, textual information tables, whatever you call it as. So we'll be referring it as dimension once it is added to your analysis services, and the column will be referred as attribute. Now let's quickly see what is the key column and what is the name column, why I selected key column and why the default name column for product key when I created the dimension. For example, if I go back to try to create a new dimension, and when I select the table, you can see it selected the key column. This is fine, and it also selected the name column. What is the difference between key column and the name column? So in analysis services, it uses the key column mainly for querying purposes, and the name column is for display purpose. So the name column is the one which you will be seeing in the front end when the users drag and drop, and then key column is the one which is behind. It can be the same. I'll show you an example. If you remember, while filling any application form, you will be seeing something like this. Select country, correct? Drop down. And it will show all the countries when you expand this, and it will show India, Pakistan, Bangladesh, Sri Lanka, United States, United Kingdom, whatever. So when you select, let's say, Bangladesh, it won't send this name Bangladesh to query and get the states. If you select the Bangladesh, it will normally display the states, right? It will fill the state. So this is what the user will see, the name of it. But behind this name, it will be tagged to the ID of it. Let's say Bangladesh, the ID is 3. When I select this Bangladesh, it will send this 3 to the database, and it will select all the states where country is equal to 3. And let's say I get 50 states that will be loaded here. So the key column is the one which will be used basically for querying, and it will be always in the back end behind the scenes. And the name column is the one which is used to display. For example, let me show you one example here. Let's take color. So let's take product key. So what is the key column and the name column? Where I can see this, if I go to the properties, and if I come to the bottom, you can see the key column and the name column, the value column is there. Now the key column is showing as product key, and the name column is nothing. Name column is not selected anything. So if the key column is provided and the name column is not provided, then the name column will also be the same as key column. It will be used product key as name column also. If I specify something else, that's a different story. But here for this particular attribute, that is product key attribute, the key column is product key, as well as the name column is also product key, because the name column is not selected. Now let me process this dimension. I'm going to quickly process this dimension and show you what data you can see when you drag and drop the product attribute from in the browser. So I'm going to the browser and I'm selecting product key. So what you can see is IDs. So the product key 1, 2, 3. So it is using ID product key for querying as well as for displaying. What user can see is also the product key. Now going back to the same, for this product key, I'm going to the properties. In the name column, I'm going to make some change. Okay. So in the name column, what I'm going to do here is I'm going to display name instead of key column. So I'm explicitly providing the column or selecting the column that I want to show to the users when they drag and drop this product key. If I leave it as is, it will show product key. Or if I specify something like, let's say, English product name, where is that English product name? Yeah, here it is. So here explicitly I provided the name column should be product. So it will be using product key for querying purpose, and for display purpose, it will be using name column. Let me quickly process and show you the output. So let me click on close and let me reconnect. This is the button to reconnect, or you can click on reconnect here. So if I click on reconnect and I selected the product key, and you can see it is not showing key value here, but it is showing the product name. Why? Because I asked the server to display this instead of the key, but use the key for querying and all the purpose. Now I'm going back. Instead of this, I'm selecting color and I'm processing it again. So now what it will show if I try to browse the data of a product key attribute. It will be color because I selected the color as the name column. If I reconnect it, you can see the first product is adjustable race or something like that. The color of that one is not applicable, or NA, and the color is NA. This product color is black. So it won't do anything. Whatever the column you specify in the name column, it will get that value and it will display that value. So it is mainly for displaying purpose. And if you see the third one, which is value column, this is more like to carry extra luggage. Like if you want to carry some extra attribute, extra column value, which will be used for your analysis purpose or in your MDX querying, then you will be using your value column, which is very rare to use. I never use this, and it's more like carrying an extra column, extra luggage with the attribute. So if you see this particular attribute, if you try to query the key column, it will display you product key. It will try to, if you try to query name column, it will display color. And let's say you selected product name, and if you try to query the value of this particular attribute, it will give you the English product name. So in one attribute, you can get 3 different values, and you will come to know, or you will understand this when we discuss about MDX queries. Now, let's see what is hierarchy span and how to create the hierarchy span. For that, I prefer to have time dimension, which is very good for creating hierarchies, natural hierarchies particularly. So let me go to dim date. The key column is selected, name column is selected, or here itself I can select a different name. If I select as a Spanish day name of the week, whenever you drag a key column, it will show the Spanish name, day name of the week. But I don't want to do that. Let it be as is. Click on next. I selected all the attributes. Click on next and date and finish. So here you can create hierarchies. Hierarchies is a tree view kind of display, like which can be used predefined tree view, which will be used by the users to make their work easy, and also the querying and the processing will be very good if you define hierarchies wherever possible. But don't create junk hierarchies. We'll be discussing about that too. So first let me explain you what are the types of hierarchies. There are basically 3 types of hierarchies. Before going to that, let me show you how the hierarchy looks. First, I dragged calendar year, and you can see the name of the hierarchy. You can edit the name of the hierarchy by selecting here, double clicking, or click twice. Calendar hierarchy. And I've selected calendar year, and let me select calendar month, and let me select calendar quarter. It will be somewhere here, physical quarter, but I don't see calendar quarter. Let me see. Calendar year, calendar semester. I think I removed the calendar quarter. That's fine. From my data source view. If I go to the data source view and dim date, I think I removed it. Let me add that one too. Yeah, here you can see I removed the calendar quarter. Okay, let me go back to the dimension, and here you can see the calendar quarter now. Let me add the attribute. This is how you can add the attribute. If you miss creating or adding an attribute at the time of designing or creating the dimension, you can just simply drag and drop it. It will be created. Now you can see the calendar quarter. Let me add calendar quarter and let me add English month name. So this is one hierarchy now. It's just like creating, I told you, using multiple attributes, more than one attribute, you can create an hierarchy. So the hierarchy will be like a tree structure when you deploy it to the server. Let me process this dimension first to show you how the hierarchy looks in when the users try to browse the cube. Let me click on run, and it's successfully processed. And somewhere you can see the hierarchy also processed. You can see the hierarchy is processed. Okay, close, and let me go to the browser option, and this is the hierarchy, calendar hierarchy. Hierarchies normally shows on top, and if you click on all, it will show all the years. And if I click on 2005, it will show the semesters, because that is the second level or second attribute I used in the hierarchy. When I click on any one, then it will show the quarters. When I click on the quarter, it will show the month, and here it shows the month, and here the semester 2. And if you click on that particular member, it will display what level you are highlighting. Here I highlighted semester, here I highlighted quarter, so it is showing calendar quarter. And when I expand its month, it will show English month. So this is the advantage, and it has a lot of advantages apart from having a tree structure, and user can use it for their analysis purpose. It's really, it improves the performance, and it helps a lot while creating the calculations. I love hierarchies when I work on MDX calculations particularly. So now you have seen how to create the hierarchies, right? Basically, how the hierarchy data will be like, it will be having all on top, and it will be having members on the next level. We call it as levels. So this is one level, this is one level, this is one level, and this is one level. If you see, this hierarchy has 4 levels added. Okay, on top of that you will have all by default. Now this is the level 1, and this level will have members, and this is the level 2, and this guy will have semesters or whatever. I'm just showing an example how the data looks, um, how the hierarchy structure looks. Okay, and this is level 2 3, and level 4 is here. So if you ask me who is the great grandparent of this guy, this particular member, I can go to this level, I can go to this level, I can go to this level, and I can say this is the great grandparent of this particular member. So this is how the hierarchical structure, normally the sample hierarchical structure looks. Now let's see what are the different types of hierarchies. This is very important into the question. You can have 3-4 stars before this question, because this will be asked for sure. And there are basically 3 types of hierarchies. One is natural hierarchy, another one is a natural hierarchy, and the third one is ragged hierarchy, RAGGED. So natural and unnatural is 2 different, and the third one is a little different name, that is ragged hierarchy. So first let's see what is natural hierarchy. So natural hierarchy is something which started at the same level and which ended at the same level. So each and every member will have children. For example, the hierarchy level starts here. So this guy should have members, this guy should have members, this guy should have members, and this guy should have same way. So there should not be any gaps. So every level member should have the children, and it ends at the same. For example, calendar is the best and classic example for the natural hierarchy. Let's say you have 2012, this is 2013 year, this is 2014, and obviously all the years will have quarters, correct? And all the quarters will have months. and all the months will have weeks. So there will be no breakage, right? If you take the calendar dimension, so the calendar, it starts with the starting level and the ending level will be the same if you define the hierarchy. There will not be any gaps. So when you have a hierarchy definition like that, then we call it as natural hierarchy. And the best example for that one is calendar, and that is about the natural hierarchy. Now let's see unnatural hierarchy or non-natural hierarchy. So here the starting point should be the same for all the members, but ending point will differ. For example, this is the CEO, three executive directors. This is the company or organization structure. So each executive director has um, two MD, this guy, two MD, this guy. This guy has only one MD reporting to, and this guy has two MDs again. Okay, and this guy has tech lead, and this guy has tech lead. This guy has tech lead, and this guy has tech lead, and this guy don't have tech lead. This is the last level. For some departments, there is no need of technical guy or something like that. Let's say this level ended here, and this technical guy has team here like developers. This guy don't have developers, this is stopped here. This guy has team again, developers, and this guy don't have. So if you see, the starting point is fine, but it won't end at the same level. So these particular members hierarchy ended here at level 2, and these particular members, this particular hierarchy ended at level 3. These guys ended at level 4. These guys ended at level 3. These guys ended at level 4, and there may be one more hierarchy underneath this guy. So who knows? So when the starting point is fine, but the ending point varies for every member. So there will be no, the ending point, the uh, leaf level is not same for all the members, all the paths. Then we call it as unnatural hierarchy. So let's say this is a path. This path ended at level 4, and this path ended at level 3. This path ended at level 5. This path ended at level 3. This path ended at level 2. So the ending of any path or all the paths are not same, then we call it as unnatural hierarchy. And one of the example is employees and the company organization structure. And if you take the calendar here, let's take year, semester, month, whatever. So whatever path you take, it ends at the same place, because calendar is the universal and it is standard, right? So it ends at the same level. But here in this case, it is ending at the different level. So this is the difference between natural and unnatural hierarchies. And most of the cases, if you go with the date, it will be natural hierarchy. And if you go with like and employee and its reportees, then it will be unnatural hierarchy most of the cases, but some cases it will be natural too, but very, very rare. Now let's see the last one, ragged hierarchies. What is ragged hierarchy? So the ragged hierarchy, here in this path you will find blanks or breaks in the middle level, middle layers. So for example, let's say you are taking two countries, one is US and one is India, and here both the countries will have states. Let's say this guy has county here, and then let's say city, and this guy directly will have city. I'm not perfect about the hierarchy, but let's assume this is county, one extra layer in the, this is how people define in US, let's assume. And under cities you will have a what we call, let's say area. So if you see here in the one of the middle layers, it's missing. So there is missing the path. If you see, this path is fine without any breaks, and this path is fine, but this path, if you see, there is a break here. So when you have a hierarchy like this, then we call it as ragged hierarchies. So ragged hierarchies are something like the path will not be same the path will not have same number of levels. The starting and ending will be the same, but they'll be missing in the middle levels. In this case, it is missing in the county level, let's assume in this case. Okay, so, and if you see, let's say United States, you have so many states, right? And I think Washington DC is directly come here, and you'll have cities. So this is one example which I normally see whenever I look for hierarchies. And the Washington DC will have directly under cities. I think it doesn't belong to any state or something is there. I'm not sure about that. So if you see here, there is a member level missing at states for Washington DC, or something like Vatican City also. I'm not sure though. So whenever there is a missing member or null member in the middle layer, the starting and ending will be fine. It starts at the same level and ends at the same level, but they'll be missing in the middle. We call it as ragged hierarchies. In short, natural hierarchies are the one which will have the starting and ending at the same level, and the path is consistent and without any breaks. And unnatural hierarchies or non-natural hierarchies are the one which will have the same starting point, but it will have a different path. It ends at the different levels if you take different paths. And the third one is the starting ragged hierarchies. The starting and ending will be at the same levels, but you will be finding missing members in the middle levels, like you can see on my screen. So these are the three different types of hierarchies that are available on analysis services. And the other name for natural hierarchy is balanced hierarchy, whereas a non-natural hierarchy is unbalanced hierarchies. Okay, so these are the total three different types of hierarchies in analysis services dimensions. And there is one more type of hierarchy, that is parent-child hierarchy, where it will have a self-reference, and we will be discussing. Actually, parent-child hierarchy will fall into one of these hierarchies which we discussed, that is unnatural hierarchies, because it won't end at the same levels. We'll be discussing about how to create parent-child hierarchies in the next session.